So previous class we started discussing about the second order source free response of RLC circuit. So before going to that, so we'll try to solve. So one more problem on this. This is 6 ohm and this is 0.5 Henry and this is the current I and this is capacitor voltage V and this is 0.02 farad 0.02 farad and this is 3 ohm and this particular switch is open at t equal to 0. The switch is open at t equal to 0. So we have 10 volts. On the other side, you have 4 ohm. Okay. So for this particular problem, so find I of t for t greater than or equal to 0. Find I of t for t greater than or equal to 0. All right. So how to solve this? So how to solve these kind of problems? Right. So first thing, so we need to find the initial conditions, right? So what is I of 0 and V of 0? What is I of 0 and V of 0?
0, sir.
I of 0 is?
0.
Why 0? It's not 0, no? The switch is closed, right?
Okay.
I of
5 by
0,
3. 5 by 3, sir. Sorry, 1 ampere, sir.
it will be, this is the circuit, right? This is open circuited, right? And this is short circuited. This is short circuited, right? So now we have 10 volts here, and this is 4 ohm, and this is 6 ohm, right? So what is the current that flows through that this inductor?
1 no.
10 by,
Ampere.
10 by
One.
6 plus 4, so that is 1
Yes.
ampere, right? So what is the voltage across? What is the voltage across capacitor?
6 volts.
6 volts, right? So here this
Yeah.
current is 1 ampere. So we have 10 volts here. So therefore this voltage, so this voltage is 10. So voltage drop across this resistor is 4 into 1. So that is 4 volts. So 10 minus, so 4 into 1. So this is equal to 6 volts. All right. Okay. So once these two things are over, so we need to change the circuit. So for t greater than or equal to 0, the circuit will be modified like this, right? So we had two resistors. So this is 0.02 farad. So this is 0.5 Henry. And what is this is current I, right? And this is voltage V. So what is this value? What is the value of this resistor? What is the value of this resistor?
So 9 ohm.
3
Nine.
plus 6. So this is 3 plus 6. So which is equal to
9 ohm.
9 ohm. Okay. All right. So once these two things are done, so now this is, we need to find the source free response. So for this particular circuit, source free response. So for this particular circuit, what we have to do is we need to calculate the value of alpha. So what is alpha and what is omega naught? What is alpha here? R by 2L.
225, sir, alpha.
225. Why
So
225?
9, sir.
9 by 2 into 1 by 2. I think 9 only.
Yes, sir.
Okay. So what is omega naught? 1 by 2 into, so this is 1 by 50, 100. I think 1 by 100. No, 1 by, I think 10. This is correct?
Yes, sir.
Okay. So if you notice that, so omega is greater than alpha, right? Omega naught is greater than alpha. What does it mean? What kind of response it is?
Underdamped, sir.
Underdamped.
Underdamped, right? So it is underdamped case. So what are the roots for this case? S1, S2, what are the roots here? So roots are minus alpha
plus or minus psi
plus or minus alpha square minus omega
minus
naught square,
omega
right? Okay, so what you will get? So minus 9 plus or minus square root 19 minus 19. Is this correct? What is minus 19?
square root of 19
Plus j
J
into
root over 19.
root over 19.
root over 19. Okay, agree? Why j? So because of minus root over minus 1. So that's why you have plus j. So what kind of response you can expect that? So what is the nature of response? What is the nature of response? E to the power of minus alpha t into, what is the first term? A1
B1 minus
or
A1
A1
plus
or
A2.
B1 cos omega d t plus A2 into sine omega dt, right? So this is the one, right?
A2 no, sir.
Sir, A1 plus A2, A1 minus A2 no, sir.
No, you are misunderstood, right? So here, this ultimately these two are constants only, right? Okay. So maybe I represented it with B1. Okay.
Yes, sir, B1.
What's wrong in writing A1 and A2? Okay. There is nothing wrong here. So our ultimate objective is to find this A1, A2 values. Okay. Maybe in the derivation, right? Somehow we appeared that A1 plus A2 and A1 minus A2. So we assume that this is B1 and this is B2. Okay. Right. So that is derivation point of view only, we discussed that. But the actual thing is, so these two are constants only. So we need to find those constants. Okay. So for your satisfaction, I'm writing this B1 and B2. Okay. All right. So to avoid unnecessary confusion. All right. So now this is the solution, right? So I of t is, what is I of t? E to the power of minus 9t into B1 cos, what is cos? What is the next term? Root 19
Square root
t,
of
right?
19.
Plus b2 sine square root of 19t. Okay, so what is the initial conditions? I of 0, first initial condition is 1 ampere, right? So what is the other initial conditions? What are the other initial conditions we have? di of 0 by dt. What is di of 0 by dt?
10 by 0.02.
Minus 1 by L, okay, R into I of 0 plus V of 0, right? So what is this value? R into R is 9, right? 9 into I of 0 is 9 plus 6. 9 V of 0 is, how much is V of 0? 6 only, right? Is this plus or minus?
Plus only, sir.
V of 0
Yes,
is
sir.
plus only.
Okay, what is this value?
6.
So minus 30.
Minus
30 because R into
Yes,
I
sir.
of 0 is 9.
Minus 30.
9 plus
6 into 2 because L is half.
you mean minus 30.
Yes, sir.
Yes, sir. Minus 30.
Okay. Right. So this is minus 30, right? So what is the next step? What is our next step? So this is, you have two initial conditions. This is the main equation. So this is first initial condition and this is second initial condition. So by using these initial conditions, so we need to calculate the value of B1, B2, right? So if you substitute, this is equal to T equal to 1 amperes. So what you will get? What is the first expression you will get? Substitute that.
B1 equal to
B1 equals to
1.
1.
B1 cos root 19t plus b2 sine root 19t, for that e to the power of minus 9t, right? E to the power of minus 9t equal to, oh no, this is the one, right? This is I of t. Okay, so substitute t equal to 0, so I of 0, so this is first one is 0, so from this b1, so this is 0 means cos 0 is 1, so sine 0, so this is 1 and this is 0. So what is b1 value? b1 equal to 1, agree? b1 is 1, right?
Yes, sir.
Yes, sir.
So similarly, di of t by dt. What is di of t by dt? What is di of t by dt? So d into d by dt, if you notice that e to the power of, if you separate these terms, minus 90, b1, that means b1 this side. So b1 cos root 19t, so that is the first term. So b2 e to the power of minus 90 sine 19t under root. So this is the second term, right? So what is the first integration? What is the first part integration? You know this two integrations, right? So first one, integration of the first term. So that means how we will write this? How you will write?
Derivative, no, sir.
Sorry, derivative. So how to do? Why do you do? How do you do? So how you will do this derivative of this one? So there are two terms, right?
UV rules.
UV rule, right? D by dt into UV rule. So do this. So that means what you will get? The first term is e to the, if you derivate this one, minus 9 into e to the power of minus 9t, okay, into b1 cos root 19t. So this is the first term, right? So what is the second term? What is the second term?
E power minus 90
E to the power of minus 9t
minus root 19 B1.
minus root 19 b1
B1
into
sine root 19.
sine root
Root
19t.
19t.
Understood why we are doing this? Understood. Similarly, what is the second term? So this one, so e to the power of minus 9 into e to the power of minus 90 b2 sine root 19t. That is the first term. Second term is second term is e to the power of minus 9t b2 root 19 cos root 19t. Just check this or correct me if I'm wrong.
So correct, sir.
Correct only.
Correct, sir. Yes, sir.
Yes, sir.
Just substitute t equal to 0 everywhere. So substitute t equal to 0 everywhere. So what you will get? Substitute t equal to 0 and equate this to minus 30. This is at t equal to 0. So from that you already know the value b1. So from that you calculate b2 value.
Minus
Minus
21
21
by
upon under root 19.
Minus 21 upon under root 19. Okay. All right. So therefore, what is the final solution? b1 is 1, right? So cos 19t minus 21 by square root 19 sine square root 19 t into e to the power of minus into e to the power of minus 90. Okay. all right, into e to the power of minus 9t. So this is how to solve in case of underdamped response. In case of underdamped response. So we have another one. Try to solve this. So initially the switch is at A, right? At t equal to 0, the switch is moved to B. Initially the switch is at A, so the switch is at position A and it is moved to position B at t equal to 0 seconds. So find I of t. Find I of t. Okay. So we have answer for this, e to the power of minus 2.5 t 10 cos 1.6583 t minus 15.076 sine 1.6583 t amperes. Okay. So initially the switch is at position A and it is moved to position B. So that is the data that's given. Right. So next we will move on to the next topic. Right.
Sir, once you
Yes.
show the answer, sir.
Yeah.
Yes, sir. Continue.
Okay. Source free response of parallel RLC circuit. So before doing it, the forced response of series RLC circuit, so we'll start with source free response of parallel RLC circuit. So let us assume that we have circuit like this. Are you guys are following or am I going fast?
Following.
This is IL, this is IR, and this is IC. Right. So this is IC. So assume that this IF inductor current IL of 0. So we have some initial inductor voltage, inductor current, and capacitor voltage. So this is V. C, for example, initial capacitor voltage Vc of 0, so which is equal to V0. All right. In other words, I will remove these subscripts to avoid unnecessary confusion. So assume this is also equal to I. So initial inductor current is I of 0 is I naught and V of 0 is V naught. Right. So now I of 0 equal to I naught. Okay. So inductor current, if you know the inductor voltage, so how to express this current? So will it be 1 by L integration of minus infinite to 0 V of t dt. Agree?
Yes, sir.
Agree with this? Okay. So this is how we initialize, right? So minus infinite to 0 voltage across the inductor over 1 by L, so which gives you the initial inductor current I naught value. Right. So what is the next step? So we need to formulate the second order differential equation. We need to formulate second order differential equation. So earlier we applied KVL, right? So earlier we applied KVL. So now we need to apply KCL, right? So now we need to apply KCL. So let us assume that this voltage is V, this node voltage is V. Okay. This is when it will be V. So if we assume that this is ground, so same voltage is appeared, right? Agree? So now KCL at node V, a node voltage V. So tell me what is voltage here? So V by R, current through the resistor, plus what is this term? 1 by L integration of minus infinite to T V some lambda into d lambda. Agree? Plus
Sir.
what is the current through capacitor? C into
dV by dt.
dV by dt. So this lambda is some dummy variable. So just to avoid the unnecessary confusion, right? So what is the next step? So you have one side, you have one integration is there and one differentiation is there, right? So we have to bring all these things into one terms. What we have to do is differentiate with respect to t. To differentiate respect to t and rearranging the terms I'll quickly write that. So d square v by dt square, d square v by dt square plus 1 by RC into dv by dt plus 1 by LC into v, which is equal to 0. Okay, just verify this one, so whether this is right or wrong.
Correct, sir.
Okay, differentiate this one, and after that you need to divide with C. So differentiate this one, and after that, so if you divide with C, so you will get this expression, right? Okay. All right. With our previous knowledge, so what should be its differential equation? So how this differential equation should be in terms of S? So how it should be? We have defined something, right? If you remember that, so we have S square plus what is the second term in second order differential equation? 2 into
Alpha.
what is the
Alpha
actual?
S.
What is 2 into R by L,
Alpha
right?
into S. Yes, sir.
R
Yes,
by
sir.
L plus
R by
2 into R by L
Sir,
into S, sir.
2 is nothing in this equation.
Yes, 2 isn't there.
R by L, right? S square plus R by L plus
1 by
Plus
LC.
1 upon LC.
equal to 0, right? Now tell me what is the equation for this in the same manner. In the same manner, what will be the equation? Will it be S square plus 1 by RC into S plus 1 by LC equal to 0? Agree? This is its characteristic equation. Will it be its characteristic equation?
yes, sir.
Okay. Right. If you're still, so how we are written this one? So what we had to do is we had to assume that the solution is a into e to the power st, right? So substitute a. We have done this, right? I hope you remember. This is the step. So this is the step, right? This is the equation we obtained. So from that, so we assume that I equal to a to the power of est is the solution, one solution for this one. So based on that, so we derive the characteristic equation. All right. So based on that, so we derived the characteristic equation. In the same manner, right, so actually there is no need of this one. So general thing is that whenever we have the d by dt term, so we usually assume that, so which is equal to s. we encounter d by dt, so that is we normally assume that, so that is s, and d square by, so dt square, so we assume that is s square. Similar d cube by dt cube, so we assume as s3 to write out the characteristic equation directly, straightforward. Okay, understood? So no need to do that exercise. So simply, so replace d by dt square, d by dt, so with s, and d square by dt square with s square. So that the characteristic equation s square equal to r by, what you got? What you got? 1 by rc, right?
Yes, sir.
Yes, sir.
Yes, sir.
1 by rc plus 1 by
Yes.
lc,
Yes.
which is equal to 0.
Sir, 1 by R into S.
Yeah, 1 by rc into s. All right. So what is the next step? What is the next step? We need to find the roots for this one, right? S1 and S2 are the roots. So how this S1, S2 will look like? So how the roots for this will be look like? So if you find out the roots, so it will be like this: 1 by 2 RC, okay, plus or minus square root 1 by 2 RC square minus 1 by LC. If you rearrange these roots, okay, it will be in this form. Understood?
Yes, sir.
Okay. So now, with our previous experience, can anyone tell what is alpha here? What is alpha here?
1 by 2 RC.
So
1
1 upon
by
2 RC.
2R. What is omega naught here? 1 by
1
square
upon
root
LC.
LC. So everything is same. Everything is same. The only difference is in case of series RLC circuit, we have R phi equal to R by 2L. R by 2L. So now you have in parallel RLC circuit, we have alpha equal to R1 by 2 RC. If you notice that this is RC, so where this RC comes from, that is the time constant of capacitor circuit, right? RL circuit, RC circuit. So we have R alpha equal to 1 by 2 RC, omega naught equal to 1. So this can be written as S1, S2 can be written as minus alpha plus or minus under root alpha square minus omega naught square, right? Agree?
Yes, sir.
Yes, sir.
Okay. Same, everything is same. So we can also define the response, this alpha and everything. Alpha is, what is alpha here? Damping factor, right? Omega naught is the undamped natural frequency and all. So here the solution for this one and everything is remain same. The only difference is we have this V of t, right? So now we have this V of t, whatever we have calculated, so that is for V of t only, right? So earlier you have current expression, so now you have voltage expression. So that is the only thing. So V of t, so again we have three possibilities: alpha greater than omega naught, alpha equal to omega naught, and alpha less than omega naught. So what is alpha greater than omega naught case? Overdamped, right?
Overdamped.
Yes, sir.
So this is critically damped. And this is underdamped. Right. So we have three possible solutions. So with our same experience, so this solution will be, in case of overdamped, it will be A1 e to the power of S1t plus A2 e to the power of S2t. So this is for overdamped case. In case of critically damped, so A1 plus A2t into e to the power of minus alpha t in case of critically damped. In case of underdamped, e to the power of minus alpha t, right, cos omega dt, some a1 cos omega dt plus a2 sin omega dt. T. So this is for underdamped case. So what is the value of omega D here? What is omega D here? What is omega D? Omega
1
naught
upon-
square minus alpha square, right? Agree?
Yes, sir.
Thing is that, so no need to remember anything, right? So only thing is we need to remember these three things. In addition to that, in case of series RLC circuit, alpha equal to R by 2L. In case of parallel RLC circuit, it will be alpha equal to 1 by 2RC. So that is the only thing we need to remember. All right. Same procedure to solve this or to find out these constants A1, A2. So we require two initial conditions. So what is the first useful initial condition? So we have 0 value, which is equal to V naught. So that is the first initial condition you require. So what is the second initial condition you require? What is the second initial condition?
dV naught by
So
dt.
dV by dV.
dV of 0 by dt. So how to find that? So dV of 0 by dt. So we have this expression, right? So from this expression, right, for t equal to 0, so can anyone tell? So first one is V of 0 by R, right? So what is next one? What is this next one? The first term is V of 0 by R, right? So this is for t equal to 0.
V
What's the
naught by
next
L,
one?
sir.
Hmm?
V naught by L.
V naught by? Why V naught by L?
I naught.
Only this
Sir,
entire
zero.
thing is, this entire thing is I naught, right? Which is equal to C into, no, not equal, plus C into dV of 0 by dt, which is equal to some value, right? Or which is equal to 0, sorry, in this case. Understood?
Yes, sir.
Understood. Or can I explain again? Simple thing, we have one equation is there, right? So if you substitute 0, it will be V of 0, and this will be 0. We already calculate 1 by alpha minus alpha to 1 by L minus integration of minus infinity to 0, V of 0, V of t to dt, so which is equal to I naught, right? So that is the same thing we followed here. So nothing complex. Okay. So if you solve this one, so what is the value of dv0 of dt?
minus 1 by C
Yes.
minus 1 by C into V of 0 by R plus I naught.
Will it be the same?
Yes, sir.
Okay. All right. Understood? So how we are calculate dv0 of dt? All right. So we'll try to solve some problems on this parallel RLC circuit. Parallel, yes. Yes. Okay. So let us assume that we have some data is there. Okay. So V of 0, which is given as 5 volts, right? And I of 0, which is given as 0 amperes. L value is given as 1 Henry. And C value is given as 10 millifarad. Just turn off your mic. For R value, so there are three things: 1.923 ohm, so that first case. So 5 ohm, second case, and 6.25 ohm, so that is the third case. This is 1, 2, and 3. Okay. So this is a parallel RLC circuit. It's a parallel RLC circuit. So here R value is variable, and there are three possibilities for R value. One is 1.9235 ohm and 6.25 ohm. So for all these three cases, what we have to do is we need to find the voltage response for all these cases. So we need to find the voltage across the capacitor. Okay, so voltage across the capacitor for all these three. Understood? So once this kind of problems are given, see most of the competitive exams, so usually this kind of nature only. So first thing is what we have to calculate, straight away you need to calculate the value of alpha. What is alpha? In case, for
By 2 RC.
first case, case 1, R equal to
2.6.
1.923 ohm. What is alpha? R by, sorry, 1 by 2 RC, right? What is 1 by 2 RC?
26.
26.
Overall.
What is omega naught? Omega naught 1 by 2L, right? 10, 20,
10.
10 to the power of
10,
minus 4 under root. So that's 10 square. I think 10. Is this correct? 10.
Yes, sir.
Okay. First case, if you notice that alpha is greater than omega naught, right? What you understood from that? Alpha is greater than,
Overdamped.
so
Yes.
overdamped case, right? So what kind of solution you can expect? What kind of solution you can expect? What is the next step? You need to calculate the S1, S2 values. So what is S1, S2? Minus alpha plus or minus square root alpha square minus omega naught square. So what are these values? Alpha is 10. I think this is 10. 26, right? 26 minus, just calculate.
Sir, minus 26 plus or minus 24.
What is that? Minus 26 plus or
Minus
24
50,
minus
comma,
20
Minus
and
50 minus 2.
minus 2.
okay, I think this is the one. So what kind of solution we can expect? So V of t equal to, right? So A1 into e to the power of first root 2t plus A2 into e to the power of, what is the second root? Minus 50t. Okay. So we have some initial conditions. V of 0 is given, so 5 volts. If you substitute V of 0 equal to 5 volts, A1 plus A2 equal to 5, right? So this first equation. So what is next one? So dV of 0 by dt. What is dV of 0 by dt? Minus of V naught plus R into I naught by RC. RC or R? I think RC only. RC. So what is this value? What is this value?
Sir, minus 260.01.
Minus 260.
Yes, sir.
Is this correct? So differentiate dWRT with respect to t. So if you differentiate this one, what you will get? Minus 2 into e to the minus 2a1 e to the power of minus 2t, that is the first term, minus 50 into e to the a2, just correct me if I'm wrong, minus 50t, which is equal to minus 260. Okay. So substitute t equal to 0, so that means minus 2a1 minus 50a2, so which is equal to minus 260. Agree? Or I'm wrong? So this is equation 2. So solve equation 2 and 1. So you will get two values, A1, A2. What is A1?
So
Uh,
A1 is
A1
minus
is
5 upon 24.
yes, sir. Same.
5 upon,
So minus 5 upon 24.
and this will be
So 125 upon 24.
okay. So substitute these values. So that means overall solution is, so let's term first, right? So that means 125 by 24 e to the power of minus 50t minus 5 by 24 e to the power of minus 2t. Is this correct?
Yes, sir.
So this is the first case, right? This is the first case. Understood? So next second case, r equal to case 2. What is the value of r? What is the value of r? 6.25. Second case.
5
No,
ohm.
no, 5 ohm. 5 ohm. So calculate alpha again. Right. Omega naught is same, right? Omega naught is same. Why? It is independent of r. Omega naught is independent of r. So that's why it is same. 1 by 2 RC. One r is C is 10, right? So r is 5, 5, 10. I think 10. Alpha is
Critical
10.
damped case, sir.
It's a critically damped case. So what are the roots? S1, S2 values? What are the roots?
Minus 10
The
only.
root is
Both
only
are same.
minus 10 and minus 10 only, right? So what is the solution for V of t? What is solution for V of t? A1 plus A2t into e to the power of minus 10t. Agree? Okay. So we have one initial condition V of 0 equal to 0. So from this what you will get? A1 equal to, no, what is V of 0? What is V of 0 is given? I think 5 volts.
5 volt.
This is not 0. So A1 is 5, right? Agree? So substitute t equal to 0. So A1 is 5. Similarly, next one dV of 0 by dt. What is dV of 0? If you remember, if you notice that, so you got minus 260, right? Earlier case. So don't use this one. So why we need to use this one? This is depending on R value, right? So this is particularly depending on this resistance. We need to calculate this again. So again, we need to calculate. So V naught, okay, plus R into I naught by RC. So we need to calculate this again. So because it depends on R value. So what is the value of dV of 0 by dt?
Minus 100, sir.
Minus 100. Okay. So calculate dV of 0 by dt. Okay, it will be or dV of t by dt first. It will be a1 into e to the power of minus 10t, right? So a1, okay, into minus 10 e to the power of minus 10t. So that is the first term. Second term is a2 into e to the power of minus 10t plus a2 into minus 10 t into e to the power of minus 10t. Just cross check this. Just cross check whether I'm done right or wrong.
Correct, sir.
Is correct?
Correct, sir.
Correct only. So substitute t equal to 0 everywhere. So dV of 0 by dt. So its value is supposed to be 100. Right. So now tell me what is its value.
Minus
Minus
50.
10 A1.
Sir, A2 minus 10 A1.
Okay. So from this A1 value is already known to you, right? So what is A2 value? A2 is minus 50. So therefore overall solution. So overall solution for V of t is, okay, A1 is 5, right? 5 minus, this is minus 50. So 50t into e to the power of minus 10t volts for t greater than or equal to 0. So this is the overall solution. Understood? Understood. So next third case, R equal to 6.25 ohm. So calculate value of alpha. Omega naught is already 10. So what is alpha? Alpha is 8. So omega naught is independent of R. So that means alpha less than omega naught. So this is underdamped case, right?
Yes, sir.
What is omega d now? Omega d is 100 minus 8. Is it 6, right? 100 square minus 8 square, which is equal to 6, I think.
Yes, sir.
Okay. So now what is the solution as roots? S1, S2. There is no use of roots, right? So straight away you can calculate that. So what is the solution? So V of t e to the power of minus alpha t minus 8t omega d, right? Cos 6t, okay, a1 cos 6t plus a2 sin 6t. All right. So initial conditions, V of 0 equal to 5 volts. So from this, what you will get? What you will get from this? V of 0.
E1. I mean,
A1 equal to 5
A1
volts.
equals to 5.
A1 equal to 5. You can straight away say
so the
that.
J will also come, sir.
Huh?
So there will be J also, sir. JA2.
J to where? J? Where J will come?
So this is case of, sir, underdamped. No? So in the, sir, VT expression, sir, A1 cos omega dt plus JA2, sir, sin omega dt.
Where J will come? Okay, I think, okay. See, I think one of the thing we missed, I think. Wait, just a second. Right. So this entire thing is B1 actually. Okay. I think we forgot to discuss that. The thing is that that's raised a good point. This entire thing is there, right? So this J into A1 plus A2. So this entire thing we assumed as B2. Okay. Along with that J. Understood? Along with that
So,
J into
but when we
Yeah.
calculate any particular answer, sir, then we get, sir, sir, means whole, sir, real number only, sir. But that J complex factor is always missing, sir. Then how can we, sir, account for that?
No, that is already accounted, right? Okay. That's already accounted in when you're considering when you're calculating the initial conditions. That is already accounted. Okay, no? Just change that one. So J will not be there. So that's why every time we have written like this only. If I included that J, so that is J into B1 A1 minus A2, so which is equal to B2. Is there anywhere else I have used J?
No, sir.
No. I think we are not using. I think one problem today morning we had done. This is the one, I think. And there is this B2 is J into A1 minus A2, so which is equal to B2. So already we assumed that one, so that means this is the solution. Okay, so there is no J term here. I'm just, yeah, here also we have written J, so there is no J here. Okay. Actually, the J term in one older books, you will actually find that with J terms, right? Okay. So nowadays, what they observed that with using that J or without using that J, so there is no much change. So when you assume that the constant, okay, so that's why this this error is. So no need to use that J. So that is J is inherent in that constant. Okay. So what is the next thing? We have 0 equal to A1 equal to 5, right? So what is the next step? We need to calculate. So dV of 0 by dt. What is dV of 0 by dt? Minus of, so what is its value? dV of 0 by dt value?
Minus 1 by RC into V naught plus I naught into R.
So what is its value?
Sir.
Minus 80,
Minus
sir.
80. Okay. Right. So do the differentiation. So first step is we need to do the differentiation of this one. It's slightly tricky, but it's easy, right? You can do it, right? Minus e to the power of 8t. What is the differentiation? What is in this one? Minus 6a1 into sine 60 plus 6a2 into cos 60. Okay, so this is the first term. Right, and the second term, so so differentiation of the second terms, right? So it will be plus minus 8 into e to the power of minus 8t as it is same term, a1 cos 60 plus a2 sine 60. Okay. Understood? So substitute t equal to 0. So dv of 0 by dt, so which is equal to minus 80. So what is its value? I think minus 8a1 plus 6 minus 8a1. Okay, one term, and 6a2. Just check it out.
Yes, sir.
Yes, sir.
So this is 60. So this is second equation. Substitute. I already know the value of a1, right? So you already know the value of a1. So from that you can do the rest, right? So you can calculate a1 value in 5. So what is a2 value?
Minus 20 by 3.
Minus 20 by 3 means 6.667. Correct? So
Yes,
now
sir.
v of t is e to the power of minus 8t 5 cos 60 minus 8, sorry, minus 6.667 sine 60. Yeah. So this is how, right. All right. So if you notice that, right, So we have, so R value is 1 point, first case we have 1 point, something, what is the value? 1.9. What is the value of R? 1.932, right? So for 1.923, so this is over damped. For 5, it is under damped. And for 6.25, for 5, it's critically damped. And this is under damped, right? So what you understood that for same initial conditions and same inductor and capacitor value, for same initial condition, same inductor value, if resistance increases, right? So degree of damping increases, and the in other words, the response will be differ. The response will be differ, and it is changing with the resistance. Okay, it is changing with resistance. So usually, if it is less than 1.923, so we can say that you can say that it's over damped. If 5 equal to 6 ohm, it's critically damped, and 6.25 it may be under damped. Okay. All right.
Sir,
Yes.
sir, will this behavior be observed only in the case of source-free response of parallel RLC circuit?
No, same only. Okay. The
Sir, in
response is
series
same.
also, sir.
Hmm? What you're saying?
Sir, in series RLC circuit also, sir, if we keep everything same, but if R is increasing, then we'll get the same behavior.
Same behavior.
Okay, sir.
Thing is that, so here it is settled around 0. Okay. So for we already shown so we already seen this one, right? Okay. So the value is trying to come to 0, right? Okay. So the value is trying to come to 0 in case of source free response. If you have source response, this is actually what exactly, this is more interpretation of if you have all under 3, right? So this is over damped case, right? So this is critically damped case, and this is under damped case. All right. So this is over damped case. So one is critically damped case, and the other one is under damped case, right? So you can see that. So here this is actually in case of source free response. In case of source free response, this is supposed to be 0 volts or 0 amperes. Okay? In case you have some steady state value, this is supposed, and if you have some steady state, if you are exciting with this one, so this is source voltage or source steady state value is the steady state value of this particular circuit, right? So this is how exactly we can differentiate the over damped or under damped or critically damped case. Okay. These are not actually drawn to the scale actually. Just giving an illustration that, so how these things are there. Under damped case, critically damped. If you notice that the critically damped case is just a boundary line between over damped and under damped. So we'll stop here, and in next class we'll discuss about